For 7.2b, we're actually going to be adding and subtracting the rational expressions, but we need to do a little bit of work with LCDs and LCMs. So I want to practice first really quick with just some numbers. So just off to the side or at the top of your paper, I'm going to give you the numbers 14 and 4. And I want to find the LCD of this. Now you might be able to do this in your head, but I want us to do it all written out so that you see it, how it's done with numbers, and then we're going to apply the same ideas to expressions and variables. So what we want to do here is we want to break down 14 and 4 as much as we can. So how would 14 break down? 2 and 7. So 14 is the same as 2 times 7, right? How does 4 break down? 2 and 2. Okay, so we want to find the LCD or the LCM, same thing. So do you guys remember for you guys it was yesterday, if I have anything in common, how many times do I have to write it?
Once.
Just once. So the 2's we only have to write, or one of the 2's we only have to write once. And then we're multiplying by everything else that's not in common. What is not in common?
14.
A 7 and a 2.
You can't multiply them together.
We do want to multiply them all together. So 2 times 7 times 2 gives me 28. So my LCD here is 28. Is everybody okay with that process? Yeah? So let's apply it to a couple of expressions. So we're going to do this with just expressions now. Same idea though. We're going to do it with 2. First we're going to work with 4x and 2 times x minus 1. I'm going to zoom in because I did not give myself a lot of room to work with here.
What's the other one? It's 3x squared what?
3x squared minus 2x minus 8. There's our 2 expressions. We're going to work with these first. So we want to take here 4x, and we want to break 4x down as much as possible. How does the 4 break down? 2 and 2. So this is 2 times 2 times what? Times x. And then 2 times x minus 1 is actually kind of nice for us. It breaks down to 2 and x minus 1. So we leave them separated. Okay. So the LCM here, first we need to write out what's in common. Do these 2 terms have anything in common?
2.
A 2. Just one though, right?
Yeah.
So they have 1, 2 in common. So then we have to include now everything that they don't have in common. So what do they not have in common?
A 2.
There's a 2, there's an x, and there's an x minus 1. So my LCM would all actually end up being 4x, and you can leave x minus 1. You don't have to distribute. So my LCM there would end up being 4 times x minus 1. Is everybody, or 4x times x minus 1. Is everybody okay with that? Yeah? So let's try the next one. We're going to work with a few more expressions here. We have x squared minus 16. 3x squared minus 2x minus 8. We want to break these down as much as possible, which means we're actually going to do what? In this one is a difference of 2 squares. So 9x squared minus 16 factors to 3x plus 4 times 3x minus 4. Right? So far? Yeah? What factoring method would you use for 3x squared minus 2x minus 8? Anybody else know? What method would you use? Bottoms up. I'm not going to make you do bottoms up. I'm just going to give it to you factored. Okay? All of this ends up factoring to 3x plus 4 times x minus 2. Okay. Okay. So now we need to find the LCM. What is the multiple of both of these that they have in common? So remember, a multiple is something that the terms multiply into. A factor is something that they break down into. So a multiple is the opposite of a factor. Okay, it's something that the term multiplies into. So the first thing we're looking for is what they have in common. Do these two terms, after we factored them out, have anything in common? Yeah, what is it?
3x plus 4.
3x plus 4. Since both of them have it in common, how many times do we have to include it? Just once. So anything that's in common, ever, you only have to include once. So this is going to be 3x plus 4.
And you put a 3x minus 4 and then an x minus 4.
Now, since we're looking for a multiple of each of those terms, we have to include every single term for both of them. Meaning, we have to include everything that's also not in common. So we also have to include 3x minus 4 and x minus 2.
Assuming that's going to be dot, just put that there.
Our LCM for these two terms would be 3x plus 4 times 3x minus 4 times x minus 2. Okay? Is everybody okay with that? Okay, so example 1, what we're actually going to be using this for is finding common denominators, but I wanted to practice with you guys first before we actually started applying it. So example 1, we have 3 over x plus 4 minus 1 over x plus 6. Okay, now this goes all the way back to elementary school. Can I subtract these two fractions right now?
Yeah.
No, why not?
Because the bottom are the same.
They don't have common
Denominator.
denominators, so we need to find a common denominator. That's why we've been practicing in that previous little bit of work. Now for this one, it's not too bad. We have x plus 4 and x plus 6. Both of these are already broken down as much as they possibly can be. So my LCD, which is the same as the LCM, is going to be the same process as what we just did. So the first thing we need to find is if they have anything in common. Do these two terms have anything in common? No. This one's an x plus 4 and this one's an x plus 6. So then I have to include everything that they don't have in common. So what do they not have in common? X plus 4 and the other one is x plus 6.
What do you think we use this for in mind?
Okay, so my LCD is x plus 4 times x plus 6.
Obama. I'm sorry.
Okay, so this is going to be my least common denominator, x plus 4 and x plus 6, because x plus 4 goes into that, and x plus 6 also goes into that. Is everybody okay with that so far?
Yeah.
Okay, so I want to do something at the very top. You don't have to write this down, but I want to use what we already know and kind of apply it to these kinds of problems. So I have a 1/2 and I want to add 1/5 to it. I can't add them because we don't have common denominators. What would the common denominator be? 10. How would I turn this denominator into a 10? Multiply top and bottom by 5. What's missing, right? How would I turn that one into a 10? Multiply by 2. So let's take that idea and apply it to here. If my LCD, or my common denominator, is x plus 4 times x plus 6, and this term already has the x plus 4, what do I need to multiply by? X plus 6. So multiply the top and bottom by x plus 6. If this term has x plus 6, what do I need to multiply by to get the common denominator? X plus 4. Now all my work is a little squished, so I'm going to write it all out again. So this would become 3 times x plus 6 over that new common denominator, x plus 4 times x plus 6, minus 1 times x plus 4 all over x plus 4 times x plus 6. Now I have common denominators. So I can put the whole thing over the common denominator, x plus 4, times x plus 6.
Oh, like.
Okay. 3 times x plus 6. What am I going to do with that, guys? So this is 3x plus 18. And then this one right here, I have minus 1 times x plus 4. What am I going to do there? Distribute the negative 1, yeah. So you're going to distribute that whole negative 1. So that's minus x minus 4. Almost done. We're going to combine like terms. 3x minus x gives me 2x plus 4, 14. This is 18.
Then you got common denominator.
All over x plus 4 times x plus 6.
Then can't you like create a common factor on top?
Yep, there's a GCF on top. So factor out the 2. And the reason why we want to factor out the 2 and the reason why we leave it all factored in the denominator is because there could possibly be a cancellation. In this problem, does anything cancel?
Yeah.
Really?
No.
No. So you can leave your answer factored like this. Nothing actually cancels, but you can leave your answer factored. So then you're done. Okay. x² minus 5 all over x squared plus 5x minus 14 minus x plus 3 over x plus 7. Okay, so what we need to do here is we need to find a lowest common denominator. So before we do that, we need to factor this out so we can see what the individual factors actually are. So I'm going to do that work off to the side. X squared plus 5x minus 14. We want to factor that. What two things multiply to negative 14 and add up to 5? Yep, x plus 7 and x minus 2. And then x plus 7 is nice because it doesn't have any other factors, so it's its own factor. So my LCD here, first I have to find what's in common. What's in common here? They have an x plus 7 in common. And then I also have to include everything that's not in common. What is not in common? X minus 2. So my LCD is going to be x plus 7 times x minus 2. So, do I have to change this fraction at all? This already factors to x plus 7 times x minus 2, so it already has the common denominator. So I don't have to change it. So I'm going to just rewrite it.
But could it have the x minus 2 on top of the bottom?
It does. And then I'm going to factor the denominator just so that it's in the form of the common denominator. Okay, but this one has only part of it. What part of the LCD is it missing?
X minus 2.
The x minus 2 part. So multiply the top and bottom by x minus 2. Okay. So, in our numerator, this is going to be minus. Okay, minus. This now has the common denominator of x plus 7 times x minus 2. And then we need to figure out what goes on top. So, if I have x plus 3 times x minus 2, what would I be doing? Foil or box? I'm going to do it in my head, if that's okay with everybody. X times x gives me x squared. X times negative 2 is negative 2x plus 3x gives me what? Negative 2x plus 3x. Positive x. And 3 times negative 2 gives me negative 6. Now all of this is in parentheses, so when I want to put it over the common denominator of x plus 7 times x minus 2, what do I need to do with that negative?
Distribute.
So distribute the negative. So that's going to be x squared, we're almost done, minus 5, minus x squared, minus x plus 6. Last thing, we need to combine like terms. So I have x squared minus x squared, which both cancel and give me 0. So that gives me negative x, and negative 5 plus 6 gives me plus 1. All over x plus 7 times x minus 2. Okay. Alright guys, so we need to find, we don't have common denominators here, but this time we have to worry about 3 different denominators. So the very first thing I need to do is make sure everything is factored all of the way. X squared minus 25. Yep, that's a difference of 2 squares. So that's going to be x plus 5 times x minus 5. Okay. X minus 5 is x minus 5, but I would put it in parentheses so that you remember to keep it together. And then we have our x plus 3, and I would put that in parentheses to make sure that gets kept together. So we're trying to find the lowest common denominator that all of those denominators can be multiplied into. So the first thing we need to look for is if there's anything in common. Do you guys see anything in common in any of these? Yeah, 2 of them have x minus 5. How many times do we have to write it? So write it once, x minus 5. And then we have to include everything that's not in common as well. So what's left over that's not in common? There's an x5. And what else? And x plus 3. So our lowest common denominator is x minus 5 times x plus 5 times x plus 3. Okay? Now, let's look at each term. What we're going to do, we determine the common denominator. All I want to do now is to get that common denominator. So this x squared minus 25, that's x plus 5 times x minus 5. So what's the only term from the LCD that it's missing? X plus 3. So you're going to multiply the numerator and denominator by x plus 3. Okay? Okay, the second term is x minus 5. So what are the terms that one is missing? X plus 5, x plus 3. So you're going to multiply top and bottom by x plus 5 and x plus 3. And then the last one is missing which term? X plus 5 and x minus 5. So you're going to multiply numerator and denominator by that. Now, this is the hardest part of the entire problem. Everything from here is FOIL, distribute, and combine like terms, which you all know how to do. It's just a matter of patience. Okay? So that's what I want you guys to try while you're doing your homework. Do not give up just because this looks like a lot of, I know it's a lot of work, okay? But you can do it.